Doesn't everyone want to be Giselle? I mean, I would.
At some point, yeah.
All right, and then we've got Andrew and we've got Lewis. All right. Das ist gut. All right, last night's homework. How'd it go?
It went well except for one problem.
One problem.
There's one problem. Okay, what's the one
Wait,
problem?
I figured out how to do 17 though.
Did you?
You figured it out?
Yes.
What's the one
Like
problem?
once you like said it was, I would have thought it.
It
Again,
was just it was actually easy.
he gave me like a single step to do, and I was like, oh. Like, he
That was your
just gave me a
work?
single step, and I was like, oh
Yeah,
yeah.
that's fine.
All right, here we go.
Yeah, I was like, oh.
Look at this beautiful work that not Giselle but Myra has up here. Okay, I'm just kind of scanning. There's stuff that I like. There's some stuff that I don't like. One thing that I think could be better is on problem number 10 here, although like I think maybe what you're doing, Myra, is you're doing some side work. Right, you're like doing some work in like the numerator. What I would say then is don't put the equal sign. Because as soon as you say all this equals all this, I have to be like, you're linking things that are not true. Okay. This is equal to the numerator, but it's not, oh yeah, let's not do that. So I think going from here over to here, that's good. Because this limit is equal to this limit. H's cancel, we're good. Take the limit as h approaches 0. I think that might be the right answer. Yeah, Lewis.
Can you do work on the side, like?
Work on the side is fine.
No, I mean, like instead of putting equal, just put like.
Yes, like this work that you did over here, Myra, is great work. Do it on the side. Do it on the side, but you want to be really cautious with your using that equal sign, because that equal sign says these two things are equal, and they're not actually equal. Okay? All right, thank you for letting me just like take the paper from you. All right. I am not picking this assignment up for a grade yet. Part of it right now, I just want you guys to like get back into the habit of like, I do homework, and I learn these things, and all is going to be okay. Aaron.
Can we go over 13B real quick?
13B, let me give that back to you. Can you see 13B? 13B.
Same page, just at the very bottom.
Assignment number 2. Oh, you know what? We're not ready for that one. That was my bad.
Okay,
Yeah, so I was like, yeah, I was like,
My bad. My bad. My
I was
bad.
like, I have zero clue how to do this.
Oh my God, Aaron had zero clue how to
Zero
do
clue.
it.
So I was like, oh, this page.
Is the answer 1? I believe it is. All right, yesterday, where did they go? There was a stack of paper. I just had them. Here they are. Celeste, why are you doing that to me? All right, what I have for you, and this really needs to go in your calculus binder, which I don't see any
I have
calculus binders. Other than Aaron. Oh, okay. Yeah.
It's sections 1 and 2 on assignment 3.
There you go. Okay. So homework tonight is assignment number 3, sections 1 and 2. Okay. Assignment number 3, sections 1 and 2. And whenever it says assignment number, it's in the like other packet.
So this.
Yeah, it should say like the problem set packet. All right. So as we progress through this unit, Stephen, are we filming?
Yeah.
Yeah. Stephen, you sure?
Yeah.
Okay. All right. So as we progress through this unit on limits, you're going to find lots and lots of different ways to evaluate limits. Sometimes you're going to use direct substitution, but I need you to like really lock into your brain. Direct substitution is kind of like cheating. Anybody remember why it's kind of like cheating? Why is direct substitution kind of like cheating?
Because when working with limits, we're not actually concerned with what happens at that value.
Exactly. When we're working with limits, you're asking the question, what happens when you get close? It's not it's not the same as asking what happens when you're there. Direct substitution, you're like, I'm just going to plug in and it's going to be okay. Sometimes that'll work because the function behaves nicely, but that doesn't always work. So other things that you did, maybe like what you did in the homework last night, there was maybe like 1 or 2 problems where you like did like a table of values, you used your calculator. Sometimes you're gonna do some algebraic manipulation. Sometimes you're gonna be like, oh, I know what that graph looks like, got it, locked in. Other times you're gonna pray. You're gonna pray for divine inspiration, and sometimes it will come. So here's what I want to do. I want you guys to get a little bit of practice. This should be on page 19. There are 10 limit problems that I would expect you would be able to do in 5 minutes or less on the take-home quiz that you're going to get tomorrow. Yes, I just said you have a take-home quiz tomorrow. Okay, and on the take-home quiz, you would not be allowed to use your notes or anything else. What I'm totally okay with you guys doing right now, though, is if you need your parent function survival guide that just got delivered, you can use that. You guys have 5 minutes. You can work with one other person in the room. I want to get you a partner. Would you be okay working with those two? It's not those two. Boys are bad. Boys are bad. All right, see what you can do. Use that parent function survival guide if you need it.
But just only talking about them, right?
So we can do this one.
Hmm? Are you sure? Oh, unbound behavior, you're right. No, I said flip it. Like, whatever page you're on, it's different.
Oh, you do this one, I'm doing this one.
Okay.
Oh, yeah. Oh, where are you? Which one's that?
I'm assuming you're in polynomial. Can I get your sign syllabus? I just need the last page. I want you to keep all the other stuff. Thank you. Right, Myra and Celeste. Thank you, dude.
No, it looks like it.
And Steven.
I think it depends on which end. It's negative X.
David.
David,
sorry. We'll get there.
You looking at this one? In that hand?
Wait, it depends on this, on the negative. So this one, this one's K is greater than 0. It's gonna be negative. This is gonna be positive.
Is this the temptation to say does not exist? Does not exist is never going to be a good enough response.
So you're saying this one?
Less than 0.
So I go for this one.
Yeah.
And use this one, that's the positive. Yeah. So this one will be. But they're not all mine. There's no way they're all mine.
Negative.
Is that also unbounded then?
Where is it multiplied?
They literally all look unbounded.
Well, maybe for the net, we keep different ones. Just maybe for like the
Yes.
Like for this one, like for like something like this, from this one, I guess it's limited to 0.
yeah.
Because it never actually gets to 0. So this is 0.
We can just
So like, so okay, I'm making sure like not all of them are negative. Does not exist. But I guess one doesn't really.
That was just time for me to take a pen. So you guys still have plenty of time. 42 seconds left. Plenty of time.
Okay.
Let's get these two.
So I guess these are both on.
Well, I don't know.
Gotta go with the good.
I should give you guys a pencil.
Here, we're not supposed to do applications yet. We're not supposed to do applications yet. I did two already sent them out.
I think it would be okay, but you should have done it.
Well, they're a priority application, so they didn't have the essay with them.
Alright,
They're just
so let's go over this. We got 10 problems, let's see how many we can do between now and 8:45. I'll take a volunteer, any one of these 10 that you feel good about. And then you're frozen. Palimon, jump in there.
Number one,
Number 1, what do you got?
does not exist because unbounded behavior.
Okay, does not exist because of unbounded behavior. That is one acceptable answer, right? This is like the new College Board acceptable answer. The old answer that's acceptable too? Okay, I was going to say positive infinity would be totally acceptable in the old world. Okay? Aaron, then you're frozen.
Number 8,
Number 8.
it is 0,
Number 8 is 0.
I believe.
Now here's one of those things. If you know what the graph looks like, this is an easy one. 1 over x squared plus 1 is probably not really on your parent function list, but 1 over x squared plus 1 kind of does that. It does like this little hill shape, and it gets closer and closer and closer to the x-axis at the ends. So the limit as x approaches infinity is 0. Okay, frozen for a little bit. Yeah. Yes.
Number 3.
Myra.
Number 3 does not exist because of oscillation.
Number 3 does not exist because of oscillation. I never want to just hear does not exist. It's always does not exist because. Nice job, you're frozen. We get 3 minutes. Andrew. Number 2
does not exist because of unbounded behavior.
does not exist because of unbounded behavior. I love that answer. Now, if you know what the graph of 1 over x squared looks like, it kind of does this guy here, then the other acceptable answer would be positive infinity. You'll never see both on a multiple choice question. You'll never have to choose between the two, but does not exist because of unbounded behavior is the nicer, more appropriate answer. Okay, 3 more minutes. Who else got some stuff for me? People that are frozen, you're frozen until we're done. Celeste.
Number 10,
Number 10, what you got?
-1.
-1. How'd you do that?
I looked at the graph.
You looked at the graph. Great. Love it. All right. Celeste is also frozen. Running out of volunteers, moving to victims. Carmen.
5,
Number 5. What do you think for number 5?
0.
Number 5, you think 0. Do you know what the graph of e to the negative x looks like? Uh-oh. Uh-oh, which way? The graph of e to the negative x looks like that. So limit as x approaches negative infinity is?
Is that because of unbounded behavior or oscillation?
If my x values are approaching negative infinity, I'm coming out this way. What's happening to the y values?
Oh, yeah.
DNE because of unbounded behavior. DNE because of unbounded behavior.
Oscillation is one small.
All right, nice. Any other brave souls? Steven. 6. What's number 6 going to be? 0. Excellent. Way to let Carmen do all the heavy lifting there. Right? The graph of e to the negative x looks like that. The limit as x approaches infinity is going to be 0. Well played. Well played. Be careful with them. See, boys are bad. Lewis.
7 is -1.
7 is -1. Are you sure about that? You'd be willing to like bet a demerit for having your shirt untucked?
Whoa,
Are you sure about -1s?
it's big money.
Do it.
Okay, good. Do you know what the graph looks like?
Oh, yes, it's
Okay, the graph of absolute value of x over x looks like this guy. If I asked to describe like what's happening here, what kind of discontinuity is this? It's a jump discontinuity. Could the limit possibly exist at 0?
Yes.
Could the limit exist at 0? Exist? It could, yeah. Wait, no, because you're getting to
It wouldn't exist.
The limit cannot exist because in
Yeah.
order for a limit to exist,
They have to meet, right?
the limit from the left and the limit from the right have to be equal to each other. So is Lewis wrong with this answer?
No, he's right,
He's right, why?
because it's asking the limit from the left.
Fortunately, this is a one-sided limit. I just care about what happens from the left. So it's going to be -1. Pretty good? Okay, we did not get a chance to do tangent of x. The graph of the tangent of x kind of looks like that guy there. Vertical asymptote at pi over 2. So I'm going to say either positive infinity or dne because of unbounded behavior. Now, no one offered up number 4. Maybe because you couldn't find it in the parent function survival guide. You're like, where's that one? Where's that one? Where's that one?
It should be square root of x.
Right. If you remember what the graph of the square root of x looks like,
And just translate it.
right? Square root of x minus 2, all that work is happening underneath the square root sign.
To the right.
So I'm shifting the graph
To the right.
2 spaces that way.
Right.
Uh-huh. Right is incorrect, yes. And the limit as x approaches 2 from the right, it's got to be 0. Okay. All the friends okay?
Yes.
Good. Now here's the thing. This was pretty easy because you had access to your survival guide and you could like flip through all the things and life was good. On the quiz, you're not going to have access to that. If you are not 100% comfortable with all the functions that are in this parent function survival guide, I would maybe spend some time at lunch, as you're getting your eyebrows waxed, whatever it is, bring your parent function survival guide and make sure you get this under control because we're doing a lot with parent functions. All right, 16 minutes to light up your world and go in a whole new direction. Oh my God, I'm so excited. Some of you might decide you want to do this on your calculator, and that's okay. And if I could, is there somebody who feels really good at the graphing calculator and wouldn't mind driving my laptop?
Wait, what?
I give you they would
Basically, somebody's gonna like sit back here and drive the graphing calculator on my laptop.
That wasn't a laptop. Not a morning person.
Or an afternoon person.
Andrew, you look like a guy that can handle that. Can I move you to the back there, and you're gonna use my laptop whenever we need the calculator. You're not gonna be there forever, but probably for like the next 15 minutes or so. And you should probably take your stuff with you. All right, so let's talk about this first one. Limit as h approaches infinity, cosine 1 over h. This is not the kind of problem you would have ever worked with in pre-calculus. Your brains weren't quite big enough yet, but they are growing now. What are some options? If I said solve this problem any way that you want, what might be a way that we think about solving this problem?
You could, I'm gonna say graph.
Okay, you could graph by hand?
No, later.
Graph on the calculator, right? All right, if graphing on the calculator is the way you want to go for it. That's fine. And Andrew, is it up and running there?
It doesn't sound good.
And it doesn't sound right.
Yeah.
So what we're trying to evaluate is the limit as h approaches infinity of cosine 1 over h.
So what's it?
Wait, Aaron, is it right and then you just plug in values?
OneNote and all
You're
of
playing
that.
values, but you can just look at the table.
What does 1 over infinity mean? I told you about this before, and then you said that that's not possible.
What's under infinity?
Yeah.
Basically 0.
Yeah.
I mean, he told us before.
Okay, well then you should remember. All right. All right, so apparently my computer is a little shy here. All right, so some of you are graphing it on the calculator. And you're seeing whatever this graph looks like. And you've got to ask yourself what happens at, we're approaching infinity, right? Oh, all right, yep, close out of that. There you go. And, okay, close out of this. Andrew, you good from here? All right, so on your calculator, what does it look like the graph is doing?
That.
Where does it sound like good?
So it does like something like this,
Yeah.
and then goes back up like that. What's happening here in the middle is, fancy word for this, we talked about this already? It's oscillating. Oscillation doesn't always happen at the end. Sometimes it happens in the middle. So if you have the graphing calculator in front of you, if you've graphed it over here. Okay. And then go over to the graph. Andrew, you okay from here? Okay. If you've graphed it, you're probably going to say the answer is 1. Everybody okay with that? Okay, and Andrew's eventually going to catch up with us. I want to show you a way that you can handle this without graphing on the calculator, because you're not always going to be allowed to graph on the calculator. Now, some folks like to do this. They like to say, oh, let me find the limit as h approaches infinity of the cosine of 1 over h by saying it's the limit as h approaches, that it's the cosine of 1 over infinity. And this gets us to the issue of like, hey, Mr. Link, what's 1 over infinity? Number one, I never actually want to see anyone in this class or any other class at Yes Prep write 1 over infinity. Infinity isn't a number. It's not like 5. It's a concept. We don't ever get to infinity. The fancy word is approach, right? We get closer to infinity. You cannot use direct substitution with infinity. This is so wrong. So let me show you another notation. We're going to say as h approaches infinity, where I would plug it into is over here, this 1 over h. As h approaches infinity, well, what happens to 1 over h?
It approaches 0.
If h is approaching infinity, h is getting big, then 1 over h has to get close to 0. Everybody's okay with that? Not writing equal, I'm using my arrow for like approaching. H is approaching infinity, so 1 over h is approaching 0. 0 is not the final answer. 0 is what's happening here in the angle. Specifically, what I need now is like, oh, so now what happens to the cosine of 1 over h? Right? Because I know what the cosine graph looks like, if the angle gets closer and closer and closer to 0, what does the answer have to get closer to? 1. So, cosine of 1, oh! Approaches 1. Let's be really clear. So h approaches infinity, 1 over h approaches 0, cosine of 1 over h approaches 1. Almost done. Just make sure you answer the question. The question is, what's the limit as h approaches infinity? The limit as h approaches infinity of the cosine of 1 over h is equal to 1. It's the limit that's 1. It's not this guy over here where we're going to say equals, we're going to say approaches. Everybody mostly okay? All right, so let's push a little bit more. God, I love to push. All right, see what you can do with the second one. For those of you that want to graph. Andrew, if you could graph this on my computer. So this limit as x approaches 4, is it from the right?
Let's see.
Okay. 1 over the square root, is it 4 minus x?
Yes.
4 minus x. Graphing on the calculator is totally okay for right now. And then I'm going to rock your world. What's happening on the calculator if I try approaching 4 from the right?
Oh, that's cool. It's not good.
Doesn't it?
What's happening on the calculator?
Not good.
Nothing.
Nothing.
Yours is broken. Maybe you want to charge it? Okay. Friends over here, what's happening on the calculator?
Boom.
You graph it on the calculator, and what we're getting, we're getting it over here.
Errors.
We're getting a graph that looks like this. Okay? So what happens as you get close to 4 from the right?
Nothing.
Nothing. There's no graph. It doesn't make sense to talk about approaching from the right. There's no graph. And Andrew, I saw you like zooming out and kind of playing with the window because you are a pro. You're like, maybe the graph's all the way up here. Maybe the graph's all the way down here. There's no graph. So what happens if I approach from the right?
Nothing.
Nothing. And the way that we're going to say that, another way to say does not exist. Does not exist, I'm going to say because of a domain restriction. Okay, now before you're like, what if I don't get a calculator? Let's see what happens. What happens as I approach 4 from the right? And I think some of you are having your epiphanies right now. Lewis, what do you see?
So, you can, you get a negative on the square root and you can get it impossible.
Where?
4 minus, like 5,
4 minus
4
5.
minus 4
Can't have a
get a
negative
negative.
third.
All right, David, can you give me an example of a number just a little bit bigger than 4?
Little bit.
Yeah.
4.5.
4 point, okay. I think in the world of calculus that's a lot bigger, but okay. 4.5, right? Is it to the right of 4?
Yes.
Yes. What would happen if you tried plugging in 4.5 here?
You are left with a negative 0.5.
You're going to get negative 0.5, and then I'm going to ask you to take a square root. How do you feel about that?
You can't do that.
Because
It's a negative number.
you can't take the square root of a negative number in calculus class. In Algebra 2, you learned about imaginary numbers? Forget about them, okay?
Aw.
So the way that we can write this is, as x approaches 4 from the right, what do I know about 4 minus x? What's that approaching?
4 minus x is the
X gets close to 4 from the right. Like 4.1, 4.01, 4.001. What happens here? X gets super close to 4. 4 minus something really close to 4 is like 0, right?
Yeah.
But you're approaching from the left. I'm going to use that left because we know you have a negative number. And so then what happens is the square root of 4 minus x is undefined. So my conclusion is going to be limit as x approaches 4 from the right of 1 over the square root of 4 minus x does not exist because of a domain restriction. Okay. Question for you that's not in the handout, but I want you guys to talk to your neighbor about this. What if I change the question and said limit as x approaches 4 from the left of 1 over the square root of 4 minus x? Don't talk to me, talk to somebody near you. How does that change this problem?
Now
There's not any natural
the left means you're actually
So from the left,
It's not forever, but
yes. Good. Nice. Wait. From, oh wait, I was thinking.
ladies over here, what do you think?
Not from.
Same
the
with
left.
you, but I find
If
it
it
bad.
goes left, though. Yeah,
Wait,
that makes
hold on.
sense.
Now you have a graph, now you
Oh,
can
yeah.
approach 4 from the left. And what happens is
Oh,
you're
right,
approaching 4.
because then it turns into this graph. It turns into this graph.
If you're approaching 4, get closer, 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 closer to 4 from the left, what happens to the y values?
Basically, even not 4.
Just from that side.
The y values are increasing towards infinity. And so that's a good answer, but the best answer is going to be does not exist because of unbounded behavior. Everybody all right? All right, let's keep pushing. Oh, I love to push. Push, 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 till I break somebody.
Flip it over there.
All right. Oh, yes. Oh, do I love number 4. Oh, do I love number 4.
That's the one thing.
Andrew, I'm going to turn you off.
I'm so good at transformations.
Let's take a look at number 4. Get some clever thinking here on number 4. For those of you that are going to be tempted to graph this on your calculator, you're about to see have a problem.
Natural.
And I don't just mean the problem I'm having getting the document camera to project what's underneath it. Ah, there we go. Problem with number 4.
What is the same as like
To
What do you think, Steve?
it's an A and an X.
There's an A and an X. Yes, there's a fancy word for that. Begins with a V. Ends in ariable.
Oh, variable.
Yeah, there you go. Okay, you've got two different variables. Now, one of them is changing, one of them stays the same. Which one's changing? Whoa-oh.
Wait.
Whoa-oh. Which one's changing?
That'd be A.
Look at the notation. Which one's
A
changing?
is 0.
X is changing. A, all you know is that it's some number, it's some negative number, but you don't know what it is. In the business, we like to call this a parameter. Like, it's a variable, but it's a variable that's not really changing. We've just told you, like, it's some number, it's less than 0, that's all we care about. What's changing is this X value. X is getting close to 0. Now, my people that like to do direct substitution, some of you, you're going to be like, oh, cool, I know that the limit as x approaches 0 from the right of a times the natural log of x. Oh, that's just a times the natural log of 0. Anybody know the natural log of 0? You might want to look at your parent function so you want to look at it again. If you pop it into your calculator and you say, what's the natural log of 0? It can't be done. The graph of the natural log of x looks like that guy there. So what's the natural log of 0?
Doesn't exist.
Does not exist, it's undefined.
Domain.
So I can't plug in. Direct substitution off the table. Can't do it because this part over here is undefined. Now somebody else might say, okay, well direct substitution, sad panda, that didn't work. Oh, I'm going to graph this on my calculator. Graph it on the calculator? This is not going to work because, right, you can't graph with two variables. Now some cheaters, not cheaters, clever folks say, well, if a is less than 0, maybe what I'm going to do is I'm just going to like put in a negative number here and see what happens. I say we don't even need that. Let's use this newfound arrow notation. As x approaches 0 from the right, my x values get close to 0 from the right. I just need like 30 seconds here. What happens to the natural log of x?
If it approaches 0 from the right, the natural log.
If x approaches 0 from the right, what happens to the natural log of x? Natural log of x, I'm coming in closer to 0 from the right, is approaching negative infinity. Not done, not the answer. Because now what I'm saying is I know this part over here is negative infinity, so what about a times the natural log of x? You're frozen. The natural log of x approaches negative infinity. What would have to happen with a times the natural log of x? This has to approach positive infinity. Why is that, Celeste?
Because if it's a negative number, negative times a negative.
Oh, I heard it and I stopped listening, sorry. Because a is a negative number, a is the negative number, so a times the natural log of x has to be positive infinity. So to wrap this up, I'd want to see limit as x approaches 0 from the right of a times the natural log of x is positive infinity. That's one acceptable answer. Another very acceptable answer does not exist because of unbounded behavior. All right, friends. See you later. We're going to continue playing around with this tomorrow.
Or is positive?
Oh my God, I'm so gassed.
Oh, I just placed it towards positive and I was like, positive what? It's pretty common because of
This Spanish book.
like now I'm saying it be silent.
No, anymore.
Thanks for coming. Have a great day. Be kind to your teachers. Lewis, keep it tucked in.
I'm so serious. Like, I really.
See you later, Trailblazers.